We're going to look at inequalities in a triangle in lesson 39. And what we're going to start by doing is looking at theorem 39 and 32. And I'm actually not going to read those or go by those. I think these are kind of easier to explain since they're pretty self-explanatory. But example 1a says order the sides from least to greatest. We've got to order side AB, BC, and AC from least to greatest. Well, how you do that is you actually go by angle measures. We have angle A and angle B at 40 and 60. We can find angle C by doing the triangle sum theorem. We know that 40 plus 60 plus angle C equals 180. These are 100, so that means mental math, this must be 80. So if I'm doing sides from least to greatest, my smallest side is going to be opposite my smallest angle. Here's my smallest angle at 40, so therefore my smallest side must be BC. So I put BC first. My next smallest one, all right, 60 degrees is the next smallest angle, or the middle one. So the side opposite of that is AC. And that's the middle side. And then my greatest side, that leaves me with side AB. It's opposite the greatest angle degree. And so that's how you do sides from least to greatest. Now let's do angles from least to greatest. It's the same thing. You simply go by side. So smallest angle, or smallest angle, is going to be opposite of the smallest side. So smallest side is 14, so therefore angle Y is the smallest. Opposite of 25 is angle Z, and 29, our greatest, is angle X. And that's all you do. That's your answer. Angle Z, then angle Y, Z, then X. So those are triangle inequalities. Now let's move on to theorem 39.4, the triangle inequality theorem. Now what the triangle inequality theorem states is that the sum of the lengths of any two sides of a triangle must be greater than the third side. So example 3a says, could these sets be valid triangles? So let me explain what this is saying. When I look at these numbers, what you need to figure out is if the two smallest numbers, in this case 3 and 4, when they add up, are they greater than 5? Are they greater than the longest side? Well, 3 plus 4 is 7, and that is greater than 5, so therefore this one is a valid triangle. It's also Pythagorean triple, but that's beside the point. But this one is a valid triangle. We do the same thing here. We take our two smallest sides, look at their sum. Is it greater than 11? Well, it adds up to be 11, and that is not greater than 11, so it is equal, but it has to be greater than. So therefore, this is not a triangle. Then we look at this last one. Clearly 1 and 5 had to be 6. That's not greater than 9, so not a triangle. And that's all you have to do for those. Now let's do one that can be a little bit trickier to understand. Example 3b says find the range of values for x. Well, like we said before, triangle inequality theorem states that two sides must add up to be greater than the third side. So an inequality I could write is 7 plus 4 has to be greater than the third side, x. Well, I can do that two other times since there's three sides here. I can say x plus 4 has to be greater than 7. That's another inequality I could say. And then I could say x plus 7 has to be greater than 4. So all I'm saying is these two sides have to add up to be greater than this one. And these two sides have to add up to be greater than this one, and we already did the 7 plus 4. Now we simplify. 7 plus 4 is 11. So I'm going to write it just 11 is greater than x. When I subtract the 4, I get x is greater than 3. Awesome. And then here I subtract 7. and I get x is greater than negative 3. Well, the problem here is that a triangle side length cannot be a negative number. So in this range here, -2, -1, those are still possible outcomes for x, and -2 is not a possible measure for a side length. So therefore, we omit that one. We don't use it. We can't use it. And now we're left with 11 is greater than x, and x is greater than 3. Or 3 is less than x. So what I'm going to do to find our range, we're going to combine these x's into 1. And I'm going to flip this and switch the sign and say 3 is, what am I going to say, is less than x. So I switch these spots here, and then I switch the sign. I have to flip it. If I switch their spots, I have to flip the sign. So 3 is less than x, and then if this is less than 11, I can write it like so. So I just combine both of these inequalities to be one total inequality. And that would be your answer. Now I do want to explain the answer just to make sure you understand the concept. If I plugged in 3 for x, if 3 was x, let's see if it would work. Well, 3 plus 4 would have to be greater than 7. It is not. So that does not work. So that checks out. I'm just proving why some things are wrong. But if we plug in 4, x equals 4, well, 4 plus 4 is 8, and that's greater than 7, so that would work out. What about if it's 11? Because if it's 11, 11 plus 4 is greater than 7, and 11 plus 7 is greater than 4. So why wouldn't it work? Well, you have to look at it from the other one. You can forget about adding the other side lengths together since we're glued in on x. Remember, 7 plus 4 has to be greater than 11. These two sides have to be greater than this side, and they would not. So that is why that would not work. But that is just kind of explaining in deeper understanding or detail your range of values. And so that's how you do triangle inequality theorem. And that's the end of lesson 39.